Hi, I'm Janaka from Robert Court University, United Kingdom. I'm going to present our ongoing research on developing secure Android applications by mitigating code vulnerabilities with machine learning. The other authors of this research are Harsha Kalutarage, Omar Al-Qadri, Andrew Petrosky, and Luca Pires. The work will be presented in ASIA CCS 2022 conference. First, let's look at about the introduction of the research. Mobile application developers try to develop application and release them to the market, sometimes in a rush. The developers may not concern about the security by design concepts. And due to that, some applications can contain vulnerabilities that may lead to severe problems. But the application developers and the mobile OS vendors should be responsible for securing users from vulnerabilities. According to security development lifecycle principles, it is better to follow security-first development practices. At the same time, the code is being written without waiting until the application is completely developed. Therefore, a proper vulnerability detection mechanism is required, which can be used to enhance the security when developing Android applications. There are two ways of analyzing Android application. The first way is the most popular way. Analyze the source code, analyze the code by reverse engineering the developed Android applications. And the second way is analyze the source code simultaneously as code is being written. The first approach, the analyze the code by reverse engineering, is more popular because we can use the existing APKs and then we can reverse engineer and then identify the vulnerabilities. But the second way, analyze the source code simultaneously as code is being written, is more important or more valuable to the developers because it is considering about the development time. Researchers have developed several automated tools to identify Android app vulnerabilities with various scanning methods. However, the existing method or tools require deployment-ready APKs to perform the analysis, which is the main limitation of the existing method. Few works have been conducted specifically for Android code vulnerability detection, but those studies were not comprehensive. As per our finding, there is no proper method to detect vulnerabilities with high accuracy at the Android application development time. And there is no properly labeled dataset that can be used with machine learning to identify Android-specific vulnerabilities. Therefore, we are proposing a method to detect Android source code vulnerabilities using machine learning with static analysis techniques. And the proposed method can detect vulnerabilities in Android source code with an F1 score of 0.90 in the binary classification. That means the model can detect whether the code is vulnerable or not. And if the code is vulnerable in the multi-class classification approach with the 0.96 F1 score, the model can predict the CW category associated with the vulnerable code. The common weakness enumeration categories, the IDs, the description, and everything. So these figures can be obtained when we are using XGBoost algorithm. We have compared several other machine learning classifiers, including random forest, naive Bayes, logistic regression, and gradient boosting. And out of those things, the XGBoost perform very well. And we are proposing a comprehensive source code vulnerability dataset for Android further experiments. In the methodology of the research, we have mainly two stages: the training dataset generation process, and the second one is the pre-processing and ML model training to identify the accuracy of dataset generation and prediction. So in these two stages, the first one is about the training dataset generation. So for that, we use only the application which have the Android source code. That means the original source code, the open source application, because we are going to use both the applications as well as the source code for further studies. I will explain later on how are we going to use those things. So to download the APKs and the source code, we use the Fostroid project because it is providing free and open source Android applications as well as the source code. So this is referring to the Google Play as well as GitHub. So we downloaded or scraped both the APKs and the source code, and then we use two tools, the MobSF and the Quark, for vulnerability analysis, the labeling process. So we have done the data collection using scraping for Fostroid project, and then for the data labeling, we use two tools, MobSF and the Quark. none of these tools, the MobSF and the Quark, can use to detect or predict vulnerabilities in the source code at the development time. So that is the main limitation of these tools, but these tools can perform very well with high accuracy to identify the vulnerabilities for pre-developed applications, APKs, or the source code, Android source code. Once we scan through these tools, we can prepare the vulnerable dataset, the initial vulnerable dataset, which contains the vulnerable and the non-vulnerable source code samples, as well as if there are any vulnerable codes, then the CW related details associated with it, also included in this vulnerable dataset. Once we have this vulnerable dataset, we use pandas libraries to perform the pre-processing and feature engineering processes. And for the pre-processing, we use several pre-processing techniques such as string removals, comment removals, and so and so. And for the feature engineering, we use 1 to 3 n-grams because it is more accurate than the other approaches. We tried the other feature engineering approaches also, but we identified that 1 to 3 n-gram is the most suitable approach for this one. And then we use the feature vector to train our model. So here, as I mentioned earlier, we use several machine learning classifiers and XGBoost perform well. I didn't explain previously why we use the APKs and the source code, the both approaches. So the reason for that is, for subsequent studies, we are going to check whether we can use the APK reverse engineering approach or the source code, original source code, using original source code, whether we can detect the vulnerability. So we are going to compare the two approaches and then identify the best approach for the vulnerability detections. That's why we are using the APKs, the pre-deployed APKs, as well as the original source codes. Okay, so once we have the trained model, what we did was we passed several Android source code and then check whether the model can predict very well if there is any vulnerable or not. And if there is a vulnerable associated with the particular source code, then the CWE details related to that in the multi-class classification. So the preliminary results of this research are very promising. And for the binary classification, that means whether the code is vulnerable or not. So the model can predict with 0.90 F1 score macro average, which is very high F1 score. And when it comes to multi-class classification, that means the CWE based classification with the CWE categories, we can receive the macro average F1 of 0.96, which is very promising. So based on these initial experiments, we can conclude that our model can get promising results for the binary classification as well as for the multi-class classification with XGBoost algorithm. And the generated dataset can be used for further experiment in Android source code vulnerability detection, because we have proved that the concept using the dataset for using the proposed dataset for vulnerability detection in Android. So the dataset can be used for further experiments also. Some future works or the enhancements to the model we can do, including we can integrate more Android vulnerability scanners to the dataset generation process. That means we are not just limiting to the Quark and MobSF. There are several other high accuracy scanners available. So we can include those things to the data labeling process. And based on that, we can get high accuracy. We are hoping to get high accuracy. And then we can maximize the model accuracy with enhancing the training data set. That means at the moment, we have only 1,008 applications to scan. But with the automated scripts that we have, we can maximize the number of APKs and we can enhance the training data set. And we are hoping to integrate this method as a plugin to the Android development environment, or else for the Android Studio, which can freely used by the developers to perform the vulnerability detection part. And we are hoping to integrate explainable AI to identify the reasons for vulnerabilities, not just limiting to the identifying part, but we can improve our model to identify the reasons for the vulnerabilities. And with that, we would like to thank Robert Gordon University, United Kingdom, and University of Calais, Sri Lanka, and Head Grant of Sri Lanka. Some of the reference that we used, and I would like to thank all of you for listening to our presentation. Thank you very much.